Today I'd like to show you a little bit of Overflow in action. You can see here I've set up a lot of code. Down at the bottom here I've got some code for when we handle Overflow. At the moment we're just going to leave that as is. At the top here I've got a couple of values loaded in. You'll notice that A is the largest possible positive number under 2's complement notation. And N is just 1 because if I add anything to the largest possible positive number in 2's complement, I should iterate over to the largest negative number, because that's where they wrap around, as it were. So I've loaded these two into memory, and if I go ahead and I add these, then what will happen is we get an overflow exception. I'm just using add here to show you that this is what happens. And there we go, runtime exception at this address. That's where our add is carrying out. It's over here in 10, and we have failed. Our code is not executed. Now that's the issue with Overflow, is it can kill your code dead. Now a lot of compilers will just use unsigned, add unsigned to avoid this, and that's what we'll do now. So do add unsigned, assemble, and I run. You can see that in A0 we have OX8, which is the largest possible negative number. So we've got something that might not make sense, at least it doesn't under 2's complement notation. So if I change this, it seems to think this is a massive negative number. Of course, remember that addition is the same under 2's complement notation as it is under unsigned notation. So we add the binary together in the same way. It's just the meaning that we interpret it that's different. So in this case, it looks like a negative number, could be a positive number, but it looks like a negative number, and that's why the overflow was thrown. But we want to avoid that. So one thing we can do is we can just use add unsigned and just never use add. And that would mean that we don't throw over overflow exceptions, and we don't really deal with them. Now that's maybe good because it means that our code doesn't crash just because we've ran out of memory, and this is what a lot of compilers will do. You'll notice in Java, when you have a number that's too big, your code won't just crash. You'll notice that in Haskell as well. If you have a number that's too big, it won't just crash. So we can do this. However, it's maybe not the best practice just to say to your user, oh, you got a negative number, that's your problem. Maybe it is what we want to do. That's why we get paid the big bucks in programming. But what we're going to do today is we're going to check for overflow. Now, you'll have seen the video likely before where I go through the code of checking overflow for signed, or the code to check for signed overflow. And I'm going to do the same here, but I think it'll be good to see it in practice. That's why we're going over it. So what I want to do is I want to see, okay, overflow occurs when I have two things that have the same sign, and I add them together, and I get the wrong sign out. That's what's happened here, so let's check for that. So what I'll do is I'll use an XOR, and let's put this in S1, and I'm going to check T0 and T1. Now, what this will do is, because what I'm really interested in are the sign bits, and XOR has the right behavior to act on the sign bits. Of course, XOR is bitwise on words, but really what we care about is the sign bits. Now, why this will work is because if I have the two sign bits are 1, the XOR will return that to be 0. If the two sign bits are 0, that will return that to be 0 as well. So what XOR is going to do is essentially give me back a number which, if it's positive under 2's complement notation, will tell me that they have the same sign. Now, if it's a negative number, then that means they don't have the same sign, and that should mean the overflow doesn't occur. So let's see what we do next. Well, next we check that value. So I'm going to say set greater than or equal. Of course, because a positive number, in this idea of positive, 0 is a positive number. So we'll say greater than or equal to 0. And let's set that flag in A1. And I'm going to say is S1 greater than 0. Greater than or equal to 0, I should say. So that's my first check done. Next, I need to check to see if the sign of the original ones are the same, or if they are the same, and then we want to check if the original sign is the same as the sign of the result of the calculation. So as in to say, have we added two positives and gotten a negative, or have we added two negatives and gotten a positive? Let's check that. And let's put this in A2. And what we're going to check here is we're going to check the result of the calculation, which is A0, and we're going to check just one of the numbers. Now, it doesn't matter which one, because if the sign is different, we shouldn't get overflow, and in which case that XOR will fail the AND condition that we put in later on, so it doesn't matter if they're different. because that will fail the test anyway. But if they're the same, then it doesn't matter which one I pick. So in the case where we succeed the AND condition that I'm about to put in, it doesn't matter which of those two I pick. And that might sound like a lot, and might be worth thinking about and having a look at once we finish this code. So now what I'm going to say is set less than. Now we want to check the value that's in A2. Well, no, we want to give this a result register, so where have I been putting these? A1. Let's put this one in A3. If I could type. And we want to check the value that's in A2. And I want to say if it's less than 0. Now remember, if it's negative, it will be less than 0, so we don't need to check 0 as well, which we did in the positive case. So now I have two flags, and I can check, and let's overwrite A2. And I want to check A1 and A3 are the same. Or so I want to check and see if they're both 1. If they're both 1, then overflow should have occurred. Now this is what I meant earlier when I said it doesn't matter if the signs are different, because that will already fail this AND condition, whereas if they're the same, doesn't matter which one I check to the result because they're the same, and that is the case where we would actually be in danger of succeeding with this test. So now I have a value to check. So I want to say branch if not equal. If I can remember what that is. So if that is not equal to 0, then I'll jump and I'll do the overflow. Otherwise, I'll jump into the end. So if A2 is not equal to 0, then I will go to overflow. Otherwise, if that fails, I will jump to end. And that should do it. So let's uncomment this code out. Now this code is just printing out a string. If we do have overflow, so let's assemble this and run it. Now in this case we should have overflow because we're adding two massive numbers together, or one very large positive number and one together. So it should flip over to a negative number. We should get overflow, which should mean I get a little message printed out here at the bottom. And I do. So that's us. We have managed to succeed. If I change this to 0, then we won't get our message out because we've jumped past that. So this is one way that you can deal with overflow. This is just to say you check to see if overflow has occurred, and then you could print to the user some sort of warning to let them know overflow has happened. Now there's other ways you could handle this. You could handle it via exception handling, so you use add, but you actually handle the error when it arises. This is kind of sidestepping that, and it's just printing out a warning message but not actually raising the error itself. That's everything I wanted to go over today. I hope you found this useful. If you have any questions about anything I've covered here today, please do let me know. Thanks.